Hello everyone, my name is Bindu. I am from ECE department in Srinivasa Ramanujan Institute of Technology. Today I am telling about drift currents. Introduction to drift currents. Drift currents are a type of electric current that occurs due to the motion of charged particles in a particular direction. These currents are influenced by external factors such as electric field, magnetic fields, and temperature gradients. Drift currents are commonly observed in semiconductors, electrolytes, and plasma. And next, charge carries in drift currents. In solids, drift currents are mainly caused by the motion of charge carriers such as electrons or holes. In electrolytes, drift currents are due to the movement of ions carrying positive or negative charges. The density and mobility of charge carriers significantly influence the magnitude of drift currents. And next, electric fields and drift currents. Electric fields play a crucial role in the intention and direction of drift currents. When an electric field is applied, charged particles experience a force that causes them to move in a particular direction. The strength and direction of the electric field determine the magnitude and direction of the drift currents. Next, mobility of charge carriers. Mobility refers to the ability of charge carriers to move in response to an electric field. It is determined by factors such as the type of material, temperature, and impurities present. Higher mobility leads to faster movement of charge carriers and consequently higher drift currents. And next, Ohm's law and drift currents. Ohm's law relates the drift currents. Density J to the applied electric field E and conductivity sigma of the material. J is equals to sigma E, where J is measured in amperes per square meter, E in volts per meter, and sigma in Siemens per meter. This equation highlights the linear relationship between the drift currents, density, and applied electric field. And next, temperature gradient and drift currents. Temperature gradients can also induce drift currents in certain materials. This phenomenon, known as thermoelectric effect, occurs due to the difference in surge carries concentrations at different temperatures. Thermoelectric currents can be utilized in thermoelectric generators for harvesting waste, waste heat energy. Magnetic fields and drift currents. Magnetic fields can influence the motion of charged particles and consequently drift currents. When a charged particle moves in a magnetic field, it experiences a force perpendicular to both its velocity and the magnetic field. This force alters the trajectory of the charge carries, leading to the generation of drift currents. And next, applications of drift currents. Drift currents are essential in various electronics devices, including transistors, diodes, and integrated circuits. They play a crucial role in the operations of solar cells, where the movement of charge carries generates electrical energy. Drift currents are also utilized in electrolysis process where the movement of ions facilitates chemical reactions. And next, challenges and limitations. Drift currents can be affected by factors such as impurities, defects, and scattering mechanisms leading to reduced mobility. High temperatures can cause thermal excitations, increasing the random motion of charge carriers and reducing drift currents. External noise and interference can also impact the accuracy and efficiency to drift current based devices. And next conclusion, drift currents are an important aspect of electric currents contributing to the functionality of various electronics devices. Understanding the factors influencing drift currents allows for the optimization of device performance and efficiency. Ongoing research and advancements in materials science and engineering continue to enhance our understanding and utilizations of drift currents. Thank you.